going to
si, nous voyons bien, on voit.
Okay. I'm introducing the products that are available on the platform developed in the framework of the Africultures
oui, très bien.
Project. As you can see, the services are almost 7, actually, and they are covering different aspects related to crop management, from crop monitoring to livestock, disaster mapping, water, droughts, and weather. This is almost the list of products delivered for any one of the services, and actually we have several products concerning the crop, but I'm going to skip them because first of all for the time, and possibly because you are not very much interested in the monitoring of the crops, and I understand that you are more interested in other applications. Then let me skip this part of the material of the services that we are able to provide within the platform. Then let me go straight to this one. This one, actually, the land cover map was not presented before in the other workshop that we had. But I have to say that within the platform, you can also found the land cover maps. Actually, we are not producing them, but we are taking them from what is produced by FAO in framework of the VAPOR project. But of course, we are making them available in the platform. So in the platform, you can find in the platform. You can find.
Donc, je peux essayer de les trouver.
You can find many different products that you can combine together in the
au niveau de
to monitor the sorry, I have the return of some microphones, so I don't know what happened. Then, for instance, this is a comparison between the land cover map in 2010 with the one in 2020. Of course, there was not much change.
Qui va commencer en 2000.
Yes. Actually, we are also providing
Présentement, nous sommes en train
maps. For instance, in this particular case, we have the change detection from the years 2015 and 2018. So we can check the area where more of the change occurred in this period. Actually, also, you can see there is a table describing the change that is demonstrating that the change was not very much. We have less than 0.35% of the pixels changed, then a very low amount. But also we can make available on the platform the land cover map at 10 meters. This actually was a product developed by the European Space Agency in the framework of an initiative called CCI. And then also this product can be made available on our platform, if of course of interest. And then one of the products that we are producing and is available on the platform is the maps of the burned area. This is done at higher medium resolution, means 300 meters, but it can be also done at high resolution on demand if someone is interested. Apart the burned area provided every 10 days, then with 10 days frequency, we are also providing a so-called burned areas accumulation or accumulated. This, at the end of the year, actually this product is providing all the burned area in the year. So at the end of the year, we can compare the present year with the previous year or 2 years before. And we are also providing another product that think is interesting, is the land cover of the burned area. Then we provide for any burned area the type of crop, the type of land cover that was involved in the burning, that was burned by the fire. This is, for instance, an example on the right and the left side. Different colors correspond to different characteristics of the land cover involved in the fire, then damaged by the fire. As I said, this can be also done at high resolution, but is a product that is available on demand. In order to test the capability to perform this product, we have done it only on Tunisia, but we can do it for any other country on request. Another product that is available on the platform is the soil moisture monitoring. Then in this case, we provide, also in this case with a frequency of 10 days, the status of the soil in terms of moisture, then the moisture present in the soil. The resolution is quite low. This is coming from the Copernicus product. Is the order of 10 kilometers. This is an example of a map of the soil moisture in the case of Niger for a specific period that was the 7 October 2021, last year. Together with it, we are also providing another product that is called Soil Water Condition Index. So we are comparing the soil moisture of the present decade, then the present period of the year, with the same, the average value computed in the previous 10 years. Then we saw in this way, we have an estimation of the behavior of the weather, or I mean, the climatic condition, all the condition from which the soil moisture is depending with respect to the previous years. Then this is also another product that is made available on the platform. In this case, we have values going from -4 to 4, depending on -4 means that the condition, the actual condition, as much lower than the previous year, then the soil moisture is lower than the previous year. A positive number means that the soil moisture is better than the previous year in that particular period of the year. We are also, other products that we are producing concerns the water body mapping. I'm leaving now the word to the provider of this product, please.
Can you hear me?
Yes.
Okay, excellent. We are providing the product for water bodies mapping which is federated from the Copernicus Land Services. This product is very important in order to monitor and map the water bodies extent and occurrence, the periodical water bodies and the ephemeral water bodies. And we have two different spatial resolutions, 300 meters and 100 meters. And we can see in the next slide, please, a few examples from this product from 3 different areas in Niger. We can see in the first image in the upper left corner the water bodies extent for the date of the 1st of January 2022, where the water is the water bodies are occurred, and where in the next image where the water bodies is the total occurrence and the previous month. The information covers the water bodies extended occurrence of the previous month. And the two other images below are in the two different areas regarding the Tohua and Maradi, where we can see also the water bodies extent. This is for me.
I can go on?
Yeah, you can go on. You can continue.
So the next product concerns the livestock. Then I leave the floor to the provider of this, that is Sansa, please.
Good morning, everyone. My name is Maklatse, coming from Sansa. Please confirm if you can hear me.
Yes.
Okay, so I'm going to be presenting on the livestock products that we are providing across all the pilot countries for Africultures. And first is the rangeland types maps. So these maps characterizes the distribution of rangeland types, mainly areas that are suitable for grazing and browsing. And we are proposing to do this over every 10 years. Well, it will depend as well from your needs as to how much frequency do you require this information. So in terms of the accuracy of the map, we are able to achieve 92% accuracy. And this information is generated from the annual land cover maps. While we are using land cover maps to generate the training data, and this information then is derived from Sentinel-2 and Landsat-8. Next. So we also provide the rangeland condition maps, which provide the seasonal and on-the-go pasture condition monitoring. And some of the variables that we are providing based on the Sentinel-2 and Landsat, leaf area index, the chlorophyll content, the NDVI, and the fractional cover. So all these products are provided at a high resolution of 20 meters. Thank you.
So let us proceed now with the product concerning drought. I'm leaving the floor to our colleagues from the University of Thessaloniki.
Thank you, Professor Aneve. This is Vasilis Pavlidis from the University of Thessaloniki. Can you all hear me?
Yes, we can.
Great.
And not only you.
Yeah. Hopefully, I will try to make myself clear. So I will talk about the drought monitoring and early warning service. This is based on several indicators like the ones that have been presented before, like the soil water condition index, vegetation condition index, as well as the standardized precipitation index, SPEI, which measures precipitation deficit. And the heart of the system is a methodology used by the European Drought Observatory, and you can see the reference on the top right. And we use a combined drought index to combine all these sub-indicators, and the combined index tries to have some simple and easy to understand messages regarding drought status. So there are 3 different messages with different color coding. What's the yellow one, which means that we have precipitation deficit, warm, the orange one, which means that there is also soil moisture deficit, and finally alert, the most severe one, the red one, which means that drought has started to impact vegetation status. This index, the combined index, comes with 10 kilometers spatial resolution, so it's somewhat coarse, and it's issued on a 10-day temporal resolution, usually at the end of its decade. Next slide, please. So we can see here maps of the combined drought index at the bottom middle with a gray background with a different color coding for the first decade of February, and all the different sub-indicators that have been used to construct the combined drought index for this specific period. And we can also see the standardized precipitation and evapotranspiration index, SPI, used of the previous month, January, and we use both the 3-month SPI and the 1-month SPI, and also the soil water condition index and the vegetation condition index. Next slide, please. And finally, besides the main product, which is the combined drought index, and all the main sub-indicators it uses, there are also some complementary products in the drought monitoring and early warning service, such as a monthly precipitation anomaly from satellite data, but also products coming from the forecasting service, which is the precipitation deficit forecast for the next 7 days, and also probability of extreme temperature. You can see that this stuff can also impact drought conditions. And that's all for the drought monitoring service. Thank you very much.
Hi all, can you hear me? I'm Sisto.
Yes.
Okay. I'm Sisto from the University of Cantabria. In combination with the drought index that has recently been described, we produce the seasonal forecast. We extend the production of the drought index and meteorological variables to the seasonal scale. And we have different products depending on the nature or based on the nature of this kind of forecast. In particular, we have the time series, the multi-time series for the sample mean and the anomalies with respect to the reference period. We have the different meteorological parameters, in particular precipitation, maximum, minimum temperatures, runoff over the surface, and the drought index based on the SPI and the potential evaporation at different lag modes. Complementary with this time series, we have the probability of normal or lower than normal or above than normal conditions for the next season, in the sense that this is aggregated statistics or parameter over the next 3 months. This is based on all on the Copernicus multi-system climate seasonal forecast, and we made some verification based on the ERA5 analysis and using different parameters to evaluate the deterministic and probabilistic nature of these forecasts at different spatial scales. Next slide, please. Here you have some examples. The maps are showing the SPI with 1 month of lag for this month for March of 2022. The monthly volume, which is representing positive values, are representing weather condition, and negative values are represented drought conditions. And the other map is showing the probability of the third tertile, which is the above than normal condition for the next 3 months. And as you can see, in principle, most of the members of the assembly of the seasonal forecast are reflecting weather condition than normal in terms of this SPI. As the seasonal forecast is not useful when it has not a scale, we make a deep evaluation both at continental and country level scale, and you have an example of the different parameters that we are working with. First, the temperature, which is mostly predictable in most of the countries, and in particular in Niger. The precipitation, we have a lot of problems for the scale of the usability of this parameter, but the drought index SPI with 3 months lag has a very good performance in most of the season and most of the tertiles, including in September, the season of September, October, November. We has a very good performance on the scale for both the drought condition and weather condition of Niger. So in principle, we have different windows of opportunity to make this seasonal forecast useful for the end users.